Welcome to Train Signal. You're watching a video about network topologies. In this video, we're going to start off by taking a look at exactly what the word topology means. Then we're going to go in and look at some of our physical network topologies that we have available to us. We'll look at WAN technologies, which help to take our local network and turn it into a network that can span multiple cities or possibly even multiple countries. Then we'll take a look at what a VPN is, and then we'll look at what a VLAN is. So first of all, what does topology mean? Well, a network topology is the layout of the network. Now, a topology can be physical or can be logical. And here on the screen I have some drawings of some of the physical topologies that we're going to go over in just a moment. But beyond the physical layouts of our network, we also have logical layouts. Now, we spoke about some of these logical layouts in a previous video where we talked about the concept of having a peer-to-peer type network or a client-server network. That would be an example of a logical topology. Along those same lines, later on in this video, we'll talk about VPNs and VLANs, which again get more into the logical side of our network topology. So, taking a look at the physical network topologies. The first one I want to talk to you about is called the bus. Now, in the bus topology, all of the computers are connected in a straight line on a single cable segment. And I have that illustrated for you down here at the bottom of the screen. Okay, here we have 5 computers and they're all connected to one cable segment. Now, one thing you need to know about the bus topology is terminators must be used at each end of the cable segment. So here I'm just kind of drawing in some terminators. And the reason why we have to have these terminators is to prevent signal bounce. Okay, what happens is when a computer sends out a transmission out onto the cable, that transmission travels in both directions along the cable. And electrical engineering 101, when an electrical signal gets to the end of a cable, you know what it does? It turns around and bounces back. And it just keeps bouncing back and forth until eventually the signal deteriorates. And we learned, of course, that deterioration in the last video. We learned that that's called attenuation. But anyway, in this particular instance, we need for that signal not to bounce, because if it does bounce back, well, it's going to, signals are just going to keep bouncing back and forth on the cable, and then we're going to have a problem because signals are going to be bouncing into each other, colliding, and we have all kinds of troubles. Now, another thing you need to know about the bus topology is that if you were to have a single break in the cable, so if we were just kind of break this cable, it will actually take down the entire network. Now, it doesn't look like it, does it? I mean, it looks like these 2 computers can still communicate, and it looks like these 3 would still be able to communicate. But there's a problem. And the problem is that if we broke the cable here, we now have a cable end. Matter of fact, we have a cable end on this side and a cable end on this side of the break that's not terminated. So signals will be bouncing, and therefore communication will just stop. So, real quick review. Bus topology, computers all connected on a single cable segment. Terminators must be used at the end of the cable to prevent signals from bouncing back and forth and back and forth. And a single break in the cable will take down the entire network. Next, let's take a look at the star topology. In the star topology, all of the computers are connected through a central connection point so as to basically form what looks like a star, as you can see from this diagram right down here. Now, this central connection point, although it doesn't have to be, it typically is referred to, there's a device there called a hub. And the hub is responsible for taking communication that comes in and retransmitting it out to all other connections. Now, one big difference between the star topology and the bus topology is a single break in a cable. So if this cable were to have a break in it right here, it would only take down communications with the one computer. The remaining computers, the remaining network, would still be able to communicate. But if we were to have a hub failure, okay, so if the hub goes away, well then guess what? The entire network is now gone. because if that central point where they're all connected to goes away, well, I don't know how they're going to communicate. Next, we have the ring topology. Now, in the ring topology, all the computers are connected in a circular fashion, as we have down here. And data is passed around the ring. So basically, computers will pass data around the ring in one direction, from one to the other. Just keep going around the ring from computer to computer. Now, because of this, a single break in the cable, so if we break our cable, well, that's going to take down the entire network. Why? Well, because again, data is trying to travel around and round and round, and when it gets to here, it's going to say, oh, I'm done. So the entire network will be down. Now, in the last video, I mentioned something called a token ring network. And I will tell you that a token ring network is the most common form of network that uses the ring topology. But guess what? It actually uses somewhat of a physical star topology while working logically in a ring-like fashion. So what I have drawn here is I have a hub, and actually it's not even called a hub, it's called a multi-station access unit, or a MAU. And all the computers are connected into that MAU so as to form what looks like a star. But see, the red dashed lines that I have here are how data actually travels. See, what happens is when this computer sends it in, this is really nothing more than a wiring box who will send it back out to the next computer, who will send it in, who will send it out to the next computer, sends it in and back out, in and back out, and so on and so forth. So what ends up happening is it's as though the data is traveling around the circle in a ring fashion. The nice feature about this, though, is even though it's a ring topology, because it's physically a star topology, a single break in the cable does not necessarily take down the ring. Now, it depends on the equipment that you're using, but basically what happens in most of today's technology is this port will automatically know that there's been a loss of communication, and then the ring will just continue between the remaining 3 computers. It'll just go round and round like this until the one computer comes back. So that's the ring topology, which is, it's kind of interesting because we talked about physical topologies and logical topologies, and in this case the ring can be a physical ring. I mean, it is possible to actually wire the computers in a physical ring, but more often than not it is done in the form of a logical ring using the physical star topology. Next, we have the mesh topology. In the mesh topology, all of the computers are connected to all other computers. Well, but not really or not necessarily. First of all, it typically is used in a WAN environment. So maybe this picture would be better. Here we're taking a look at 5 different cities around the United States, each of which have an office, and then the offices are each connected to each other. So it's not so much that all the computers have a connection to all other computers, it's that each office has connectivity to each other office. Now, the second thing I can tell you about the mesh topology, it is not a requirement to have all computers connected to all other computers, or even all offices connected to all other offices. So as a for instance, in this example, maybe this connection doesn't actually exist. Well, it would still be a mesh topology. Okay, mesh topology just meaning that there is fault tolerance built in, meaning there are multiple connections back and forth to each other. Okay, and the fault tolerance is, as a for instance, if this line were to go down, it doesn't mean that this city can't talk to this city. They can. They'll just go maybe through this city and go that way. Or maybe they'll go down and up this way. Or maybe down and over this way. There's many different ways for this to happen because we have multiple connections and therefore have built in the fault tolerance in case a line goes down. Alright, so those are the 4 main physical network topologies. Once you are familiar with those, the next thing you need to understand is that you can have different types of topologies working together to form a hybrid topology. The example I have here would be something called the star bus. And the reason why is because we have star topology for this local network and another one for this network and another one for this network. But each of those three networks are then connected on a single bus. So we have 3 stars all connected over a single bus topology. There is no magical rhyme or reason to the hybrid topologies. I mean, you need to understand the pros and cons of the bus, the star, the ring, and the mesh. And if you see that there's an area within your environment that could maybe utilize both, as we have drawn here, well, then you can go ahead and do so through a hybrid of these topologies. Now, another thing that I will mention is technically, let me go back a page here, I suppose we could argue that this mesh topology right here is a hybrid, right? It's not really a mesh. Look, each one of these offices looks like it has a bit of a bus topology going there. So this could be like a bus mesh, right? Each office has a bus, but then each from office to office is part of a mesh. And maybe not. I would say what's more typical these days is each office would be in more of a star topology. That's probably the most common topology used today. And then again, each office would be connected to each other in the form of a mesh, thereby giving you a star mesh or mesh star topology. All right, so now let's talk a little bit about WAN technologies. And I have to tell you, going into this, that most of this is going to be just a matter of definitions. Similar to the last video, where some of the telecommunication stuff you don't need to be the foremost expert on. You just need to be able to have a somewhat educated conversation. You just need to know that things exist. Well, it's kind of the same thing here when it comes to WAN technologies. If you are going to take your network and branch out to where you are connecting multiple offices together, well, many of these WAN technologies which can do that are going to be provided to you by a third party. So unless you plan on working for one of these third-party telecommunications companies who is providing these WAN technologies, you don't have to know every last little detail. So don't worry about confusing yourself with this. So the first thing I want to tell you before we get into the specific technologies themselves is a couple of terms here. One is circuit switching. Any technology that uses circuit switching means that a physical connection path is established between the source and the destination, or we'll even just say the two locations, typically through a series of circuits, thus the name circuit switching. But in a circuit switched network, all the data is basically taking the same path. It's kind of a dedicated path that's been created. Whereas packet switching is where the data is broken into packets. So you take a chunk of data, break it into a bunch of different packets, which will each then possibly take separate independent routes over to wherever their destination is, where they then get reassembled back into data. And packet switching is a way of getting increased throughput by being able to use multiple different channels of communication. So, what are some of these WAN technologies? Well, just to kind of start us off real easy, the first two I have here are POTS and PSTN, which are essentially the same thing. POTS is the plain old telephone service, and PSTN is the public switch telephone network. It means just that. It means using good old-fashioned analog phone lines.